Hello, my name is Fernanda,
Oh, and my name is Heather.
and in this video we're going to show you how to turn on the LED on the STM32F14RE, F411RE board using low-level programming. That means that we're going to write directly to the microcontroller's registers without using any libraries yet. So before we explain our code, we're going to address some general concepts like GPIO. GPIO stands for General Purpose Input Output, and it refers to a set of pins that we can use as digital inputs or outputs. In this case, on the STM32 board we're using, there are several GPIO ports that are labeled GPIO A, B, C, and so on. And each port has multiple pins going from PA0 to all the way to PA15. So on the onboard LED, the onboard LED it's connected to pin PA5, as we can see on this diagram. So we're going to work specifically with GPIO-A and pin PA5.
Okay, now in the code, first we include this library to use fixed width data types like UINT32T, which represents a 32-bit unsigned integer, ideal for existing registers. Then this pointer refers to the RCC AHB1ENR register, which let us enable the clock for GPIO-A. If the clock isn't enabled, the port won't work. Now, this points to the mother register of GPIO-A, used to define the mode for each pin, input, output, alternate, function, or analog. And then this point to the ODR, output data register, which let us turn pins on or off.
So now that we have declared these variables and point to each pin with its base address that it's here, we're going to set the values. First, we're going to enable bit 0 of RCC HB1ENR, which is going to turn on the clock for GPIO-A. So HB1ENR stands for Advanced High Performance Bus Enable Register for the 1. And this is a register in the RCC that it's used to enable or disable the clock signals to peripherals connected on this bus, which are the GPIO ports. As my classmate said, if the clock for peripheral is not enabled in this bus, the peripheral won't function. So we're going to use the OR function to set this value. Then with the mother, these two lines configure the PA5 pin as a digital output. Each pin takes 2 bits in the mother register, and here we're modifying bits 10 and 11, which are the ones belonging to pin 5. We're gonna use first the AND function for clearing the value, and then the OR function to set the value. And then we're gonna set the value for the ODR. So we're gonna use the OR function again, and this 0x20 stands for 00100000 in binary, which sets the ODR to bit 5. This, what's gonna do is put the PA5 to a high level, and it's gonna turn the LED on. And finally, we enter an infinite loop, which is gonna keep the program running and the LED is gonna be on. So this first program is only for turning the LED on manually.
And as a summary, we have that this program enables the GPIO-A clock. It configures pin PA5 as output. it sets, well, port A5 to high, turning on the LED, and the LED stays on indefinitely.
So now we're gonna see how this works in the board. Okay, so in the last program we used PA5 from GPIO-A, which controls the onboard LED, but now what we're gonna do for this experiment is to blink an external LED. So now we've connected this external LED to GPIO-C, specifically the pins from PC0 to PC7. So what we did essentially was that we changed the register addresses to point to GPIO-C instead of GPIO-A. We enabled the clock for port C. We configured the pins 0 to 7 as digital outputs, and we added a delay function.
And now, how is the external LED connected? Well, the LED is connected to one of the GPIO-C pins, as my partner said, with a current limiting resistor. This pin is set as output, and we toggle its state between high and low. The LED turns on and off. In the code, in contrast to the other, we created a basic daily function using a for loop. It's not precise, but enough to create a visible pause between on and off states.
So now this pointer is the same as before. What it does is it accesses the RCC HB1ENR register, but the difference is that now we enable the bit 2, which turns on the clock for GPIO-C instead of GPIO-A. And now these two addresses correspond to the mother and the ODR registers of GPIO-C, which of course means that we are now working with port C. And now these lines configure the first 8 pins of port C, which are PC0 to PC7 as digital outputs. Each pin uses 2 bits, so we're setting them to 0, 1, that means output mode. As we know, there are 4 modes, but the general output mode is configured with 0, 1.
Okay, now talking about the main loop, and we start with an OR function that sets bits 0 to 7 of the ODR register high, turning on the LEDs. It's followed by a delay, which pauses execution for a short moment. Then an AND function, which clears bits 0 to 7 and turns off the LEDs. Also is followed with another delay that it's gonna do a short pause before repeating.
So now we're gonna see how this code works for the physical connection that we've made with the blinking LED. So that's it. Now we have our first external LED that's controlled with the STM32. Thank you for watching.